Hello, everyone. Thank you for your time today for attending our educational session. My name is Ron Nolasco from International Trade Council. Before we start, I just want to make few housekeeping here. If you can hear the audio, please feel free to type in yes in the chat box, and if you can also see the PowerPoint presentation. Thank you. So this session is for 1 hour, and if you have any question on the topic, please feel free to type in your questions on the Q&A section or on the chat box, and our speaker will answer the question after his presentation. Again, my name is Ron Nolasco from International Trade Council, and I will be your moderator for today. Our speaker is Michelle De Reuter, founder of Graphene Pioneer. Our topic is the construction paradigm, building energy active buildings for a sustainable future. Learning from this webinar, understanding frontier materials and their transformative impact on building materials. Learning about the practical implementation of frontier materials in retrofitting and new construction, and why this is crucial for a successful energy transition. Discovering the environmental and economic benefits of using frontier materials in construction, gaining insights into the future of construction and urban development. Now let's hear from our esteemed speaker who will elaborate the topic. Please join me in welcoming Michelle De Reuter from Graphene Pioneer. Go ahead, sir.
Well, thank you very much and welcome everybody. I'm really glad you showed the interest for our topic. I am Michel de Ruiter from the Netherlands. I founded the company Graphene Pioneer. Um, and the interest, as the name will give it away, is graphene. Um, and with this material, we think we can really change the world. And as we all can agree, this is much needed. We have a lot of problems in the world, um, and the weather extremes are getting worse and worse. And uh, a lot has to do with the way we build our society. And in this matter, we would like to uh, make some big changes. So that I will be talking about. I'm looking very much forward to your questions because what I tell, I cannot possibly tell everything, and there will be much room for questions. And again, I will love them to answer them, at least try to answer them. Well, as I said, graphene. In our opinion, graphene will change the world in a manner that has not been seen for a long, long time in history. Um, Graphene was kind of invented um, in the 1940s, but it was purely theoretical. But people understood that it would have very, very special properties if it would be a material. They were not believing that it ever could be a material because one atom thick materials were never seen, and it was expected that they will have no integrity. But in 2004, some scientists at the University of Manchester, Andrei Geim and Novoselov, they started experimenting by using just sticky tape and put it on a little piece of graphite and then peel it off, and every time put a new piece of fresh tape on the part that they just pulled apart. And lo and behold, they actually did find graphene, one layer of atom thick graphite, which was called graphene. So they got the Nobel Prize for that discovery in 2010, and that shows you a little bit of how big this actually was. Because they already knew theoretically this would have very special properties, and indeed it was the strongest material ever measured, the most conductive material ever measured. But the all the extras, special benefits didn't stop there. It is at currently the most researched material. They have found a lot of other materials that can be isolated to one layer, and it is called 2D materials. Just if you have just only the surface, it will be called a two-dimensional material. Just for to compare, as we all know, one dimensional material you can only add or subtract in one dimension, just only in length. And two-dimensional you can has a length and a width, and three-dimensional of course also has a height. So but something else happens when you have graphene. If you put it on other materials, it starts to interact with the materials. The electrons in the graphene start to interact, and then you get new special kind of properties. And this way you can build with different kind of layers of materials, and even in the direction you put those materials, you get all kinds of different properties. And it is estimated that you can build millions of new materials with this technology. So that is why this will have a big impact on our society in the years to come. What we are focusing on here today is putting graphene into composite materials. If you put graphene into any kind of composite material, composite is, of course, a number of materials put together so they form a new material together. And if you put graphene in there, it partially passes on the characteristics of graphene to the new material. So if you put it in, for instance, concrete, the concrete will become stronger. You can make it conductive. You can make it store energy. You can all kinds of things you can do with it. And so you have a normal wall, and suddenly it will get a lot of extra possibilities. And this is what we are looking for. And one really interesting aspect is keeping energy inside of buildings. Today, the way we are insulating our buildings is like effectively a sponge. It will help for a while because it will become saturated with heat. But once the equilibrium is reached, it will pour out just like it was a sponge. If you use 2D materials with the special properties in the interaction of the layers, something completely else happens. And you can kind of direct the direction of which the energy is flowing. It will not go only in, or it will not only go like normal materials. They will enter the material and go straight outside and a little bit to the up and down and sideways. With the interlayer actions, you can prevent from going it from the layer it enters to the next layer, delay that. So this can be really interesting if you want to save energy in buildings. And it acts actually as a quantum thermodynamic barrier. It is not a violation of the second rule of thermodynamics. Because of this, you increase the complexity of the whole system. And as I said, you direct it in the way you want to go. So why would this be important? With this kind of technology, you can greatly increase the energy efficiency, and that will reduce the CO2 emissions. And for not only for the during the use of the building, but also while building it. And you can use it in new constructions and in renovations. And if you use it in constructions, that will greatly reduce the chances of energy poverty. And this will increase the chances of a successful energy transition. Um, and that is important because the, the biggest part of our energy is used in buildings. Buildings are responsible for around 30% of the total energy consumption, and of that is 60% for the cooling and heating and um, uh, the indoor conditions. Now, if you start to use graphene concrete, um, besides the possibility to make the material stronger and save a lot of concrete while building the structures, as I mentioned, you keep the energy better inside of the building. And if you want to make an energy transition that is successful, you will need to address the existing buildings with the you will need to do to make the buildings that are currently used, they will need to change as well. Of course, there's a lot of new technology going on. Buildings are made much more efficient, and that is all really important, of course. But if you only do the existing buildings, uh, it will take a long time before we make the transition and replace all the buildings. And if we start to replace all the buildings, it will of course have a big impact on the resources we need to do that. So we feel that changing the existing buildings is paramount if we want to change our energy use. Now, this shows how much electricity is used in every household in the United States. You can see that for the heating and cooling and the control of the humidity, it is far much more than any other source of energy. And this, even with electric car charging, now of course not every building has a car to charge, but for now, if we want to make this transition, if we can reduce the amount of energy we need for heating and cooling, we can repurpose that for electric car charging, which will also have a big impact on the grid usage. So all these things work together. If we want to use more electric cars and charge them at home, the energy grid network will be used much worse, and it will lead to congestion. So if we can reduce the amount for what it is used for the most, the heating and cooling, that will help to address the other needs for the energy that are associated with buildings. Now, about the quantum blaster. That is our first stage that we want to implement in using this technology in homes. It is fairly simple. You just add a thin layer of quantum plaster. That is a plaster that contains a mix of materials with graphene and other materials to form a compound that will redirect the energy in the building. It will prevent the energy from leaving the building, and it is fairly easy to apply. We are working on offering all the equipment, so and the ingredients. So you have a simple mixing device, and this will be supplied to builders and constructors, and they can use it and mix the mix on site and apply it to the walls with the normal way how they apply it today. As I said, it is crucial that we address this main source of energy use, and we need this to make a sustainable energy transition. Now, this will even be more effective if you have a poorly insulated house. It will be as effective as cavity wall filling, but a lot of homes around the world, they are not, they don't even have cavity filling as an option. So if you use this, it is comparable with the effects of energy saving. But if you do it while retrofitting, the costs are just a fraction of it. It will be, if you don't retrofit and just apply it on an existing wall, it will be comparable with cavity wall filling. But if you are retrofitting, it will be only a fraction of that price, and you can have a return on investment within 1 year. So, but this is only a start. If we start to put graphene inside of the buildings, of the structures, we need those walls anyway, right? To keep the roof up. But if we start to think about the possibilities, we have graphene inside the structure, then we can use the graphene to store energy inside the building. We can put it in the foundations of the building. We can put a little bit in the wall itself. We can put it in all the concrete elements. We can put it in wood. We are on a project to reinforce wood with graphene and make it stronger, and also possibly be a heater. That will also be possible for the concrete. If you apply a current on it and you have the right composition of the mix, it will become a heater. And for the other part, it uses the heat of the existing heating or cooling systems. So it will distribute the existing source of heat or cooling inside the building, and distribute it more efficiently around the complete building. And then it has even more purpose, because if you have this energy, which can be both heat or electricity, you can also distribute it through the other buildings in the neighborhood. The whole infrastructure is mostly concrete of our built society, so we can use this concrete to share a surplus of energy with other buildings in the neighborhood. And then it is even possible to harvest energy with just concrete and, of course, graphene. It will make it possible to excite the electrons inside of the graphene, and this will then become a source of energy. And if you have already put the energy inside the material that you are going to use to store it, to distribute it, and to use it, well, that makes a lot less of materials are needed, which we are needing now. And of course, there's another problem, because if we want to make the energy transition on just copper-based technology to distribute energy, we are way short of copper. We need new materials. So this will actually be very helpful to make this energy transition. So this is, uh, in short, my presentation. I hope it was not too difficult to understand, but please be sure to ask me anything you want, because I can understand that this is quite new, and it may sound complex. So I want to give a lot of room for questions, because we feel we are making the walls become a part of the age of AI, RDNA, and quantum computing. So I can imagine, and I hope so, you have a lot of questions for me.
All right, thank you so much for that very interesting presentation. So we're open for questions now. Please feel free to type in your questions on the Q&A tab or on the Q&A or the chat box. While waiting, we already have a few questions here, but while we are waiting, I would like to inform everyone that this webinar is recorded. So if you would like to review, or if you would like to replay, you can go to our YouTube channel, International Trade Council. So it will be posted there. And for those attendees who are not yet a member of International Trade Council, please feel free to reach out to me because we can offer free membership. Also, for all the attendees today, you will be receiving a certificate of participation for attending today's webinar. So yeah, let's move on with the questions. So I have few questions here coming from the audience. The first question is, what is graphene made of aside from carbon graphite?
Yes, well, you can use any source of carbon. Um, from graphite, it is made by a few ways. Electrolysis is one of them, and of course, the sticky tape method is far too expensive to make any kind of functional graphene. But nowadays, there's many more ways. Chemical vapor deposition is one of them. Then you heat up the carbon content and cool it down really fast, and it will assemble itself in a crystalline fashion as graphene on a substrate. There's also a flash method, and that will you will need to flash a carbon-rich material really hot for a very short flash, and then it will automatically become graphene, and it is a very good quality. It is a turbostratic graphene. That means it will be easily mixed into other materials. Then there is, of course, also a chemical way to make graphene, and this will have you mostly the graphene oxides, which are easier to mix in composites. I think a very promising way is to make graphene from a carbon content and from methane, and then use it to make graphene. And this way you can also create hydrogen, and then you have two birds with one stone. So and I'm fairly sure there will be much more new ways coming to make graphite in the coming years, but more associated with the purpose that they will function as later on. Because as I mentioned, every kind of graphene has its specific characteristics, and how you use it next in the pipeline will have an important it will be important what kind of graphene you choose. As I mentioned, graphene oxide will probably mix easier in a composite to make it stronger, but if you want to have the maximum conductivity, you have better, more pure form of concrete with less defects. So everything has to connect with each other, and this will leave a lot of room for many new options. Also in the connection with other materials that that will be found, and the alignment of those materials.
Okay, thank you. Next question. So, here you go. Can graphene convert heat and or sunlight into electricity?
Yes, but um, you will need more than that. But it can. It actually, if you have a surface, a substrate of anything, and you put graphene on it, it will already change the heat capacity of the complete set. Um, Turn it in electricity is possible, but this is also a new kind of technology that is developing. Um, Up until now, it has never been a very effective way because there was no direct knowledge that this, other than of course the solar panels, that's good. It could be done, but this is now researched very much, and yes, you can turn sunlight directly into electricity with graphene. Um, but this is going to be much more efficient in the years to come.
Okay, thank you. Next question. Can use of graphene in building walls and roofs help to deflect heat and moisture in hot and humid location?
Absolutely, this is exactly what we are working on. Um, but we found that on the inside of the building, it is most effective. There is already ways to use graphene on the outside to deflect heat, and of course, graphene is really tightly packed, so it is also the least permeable material. Um, Only the really smallest of molecules can pass it, like uh, hydrogen and helium, but then at a great speed. So it will help to work as a moisture barrier. And especially in hot and humid conditions, this is important because if you have like traditional insulation, um, you won't leave the heat out. That is impossible. And once you have the heat inside of the building, it is very hard to get rid of it. With uh, uh, a layer of graphene on the inside, you still need the air conditioning, but it will keep the energy from the air conditioning inside the building more efficiently. So it is make much more sense than to just cool a building that has already hot walls. And this heat you will get very difficult. It is very difficult to get out of the walls itself. And with graphene, you have effectively a layer that contains the heat much more efficiently on the other side of the fence, so to say. So this, especially in hot and humid conditions, we see a great purpose for using graphene, helping much more effectively than the ways we have at this point. And this is also important because, well, I don't know if you have heard this, but a group of Swiss elderly people have successfully applied to the European Commission that the Swiss government has to act more on climate change because they are, especially older people, are very susceptible to heat conditions. And heat is a silent killer. If you are exposed to a lot of heat, your body also starts to cope really bad with it, and it is, yeah, you have a very much higher risk of death because of this. And in some places, for instance, India, it is really hard to live already because of the heat. And yeah, we really see a big play in this part to help and deflect heat and moisture is exactly what we are really optimistic about, that we can have a big impact.
Okay, thank you. Next question.
Yeah.
Can we use graphene as a substitute for electrical wires and cables in a building, meaning it will power the electrical devices and lights in the building?
Yes, we are also working on this. Um, uh, you can do. Um, you could uh, uh, you could also power roads with it. Um, this is something we're working on, and there's a lot of interesting stuff going on. Um, the concrete without the conductivity will act as a kind of insulator, and you can build a layer of the conductive replacing the electrical wires um, inside the wall. And with induction technologies, you won't even need any appliances to or sockets or anything. You just place the device you want to power up in the neighborhood of the where you want to in the neighborhood of the place where the induction is uh, placed, and then you will have basically a wireless home. This will be possible, and we are also talking with companies that are going even a step further. With this technology, you could also transmit energy. This was the dream of Nikola Tesla, and uh, in this way, you will just place any device in the room that has graphene walls, and then it will start magically start to work. I'm not sure how much energy you can transfer with this yet, but as we know, if the technology exists, people have a tendency to become much better at it every time. So. But yes, theoretically, this is very well possible. I'm not sure when this will be commonplace in every home, but yeah, we're working on it already. We see possibilities, but yeah,
All right,
no
perfect.
time scale here yet.
Thank you, Michelle. Next question. Are there are there pilots or other realizations already done with buildings?
No, unfortunately, not yet. We are yeah, searching for funding to have this validation in real buildings. We have seen, of course, the effects in little places, but we still have a lot of work to do to because we have seen the effects before the effects were known as physical, what the physical properties were that made this possible. We only just found out with the University of Eindhoven which physical characteristics are responsible for these effects. And there's five separate effects that are going on. And we still want to find out which are most useful in this, in what is happening in this situation. So to improve it further. We already have a letter of intent for 200,000 homes in the US if we succeed. But yeah, we're still stuck on the validation, the foundation, the funding on the validation. But we're very eager to start this, of course.
All right, thank you. And we have one last question here. How do you see the integration of graphene and nanotechnologies impacting the affordability and scalability of energy active building solutions, particularly in the context of diverse geographical and economic environments?
Yes. Well, graphene was, when it was invented, a very expensive material. And still, if you have a 100% pure graphene, that is very expensive. But what we are looking at here is a mix of graphenes, so to say. Um, and this is certainly the first stage, the quantum plaster, is going to be very affordable. Um, uh, as I mentioned, we see that we can make it the return on investment in 1 year if you do it with a retrofit. If you're going to need new plastering anyway, just add a little bit of graphene. Okay, it's a little bit more complex than just adding it, but if you know the trick, that it boils down to that, and you will get a return on investment in 1 year, and uh, and then you start saving. So if you were talking about energy poverty, uh, this is the solution, and it is also the solution because if you well, heating is not most for the most part the biggest problem. You can have alternative ways of cooling your or heating your house, but cooling, that is the real killer in the next 50 years. A lot of people are with energy poverty are going to suffer from this really, really badly. So in this case, one of the most affordable and scalable solutions is just using a pinch of graphene in your home. Um, and as I mentioned before, it is needed because everybody wants to survive. So if you have a house that is too hot, you will do anything to keep your family safe. That's a logical thing. So this will only drive more usage of energy. So I think it's very important that we use technologies like this to bring down the energy consumption. Which, of course, if we don't, the energy consumption will even make the vicious circle of putting more CO2 in the atmosphere and making it harder to cool down. So I think it's the yeah one of the most logical steps to take.
Thank you. We have another new question here. How many years will graphene or its derivatives be available commercially for use in the construction of buildings?
Well, I would I would argue that it is available if we get the funding. Um, so how many years? Uh, yeah, that is a matter of where do we get the funding, and that is really hard. Um, I found that investors are really eager to invest in something they know. The unknowns are very tenacious to get funded. So that's like looking in a crystal ball for this moment. We have talks, very good hopes, but uh, yeah, it can be 1 year, it can be 2 years, it can be 3 years, no idea.
All right, thank you. All right, so I don't see any other questions here, though we still have more time. So if you guys have more questions, please feel free to type in your question here in the Q&A tab. While we are waiting for some questions, I would like to ask Michelle to type in his email address in the chat box so that if anyone would like to reach out to you directly, they can just copy paste the email address here.
I am,
Okay.
and as I mentioned, um, we are open to more ideas. We would love to focus on the environmental questions. We think, yeah, as I mentioned, I think this is really important, and
Mhm.
it feels so natural that we have this material at this day and age coming into existence while we just need it so much. So if you have any other questions that you feel I might be able to help you with, please do not hesitate to ask. I will also give you my phone number.
Go ahead.
And Um, yeah, and I see something with the 3D printing solutions. Graphene is also being used in the black box of the 3D printing uh, uh, the concrete, and yeah, it will help there as well.
Mm.
It can make sure if you put graphene in concrete, it will also help to hydrate much faster, and so you will have structures that are able to withstand pressure much quicker.
All right, thank you. All right, so Michelle, I don't see any other questions here. So as before we conclude the webinar, I would like to ask you for the final words or information you would like to add more before we end the webinar.
Well, yeah, as I said, contact me. If you have any environmental solution problems, I would love to think about the solutions that 2D materials, graphene, or a mix of those materials can offer.
Okay, thank you. So as we wrap, I want to thank our speaker and attendees for dynamic discussion on energy active buildings. Together, we explored how these innovations are reshaping construction for a sustainable future. Whether you're an architect, engineer, policymaker, or student, your engagement that has been invaluable. Let's carry forward the insights gained by today's to drive innovation and collaboration in sustainable construction. Again, thank you for joining us today, and let's continue building a greener, more resilient world together. Again, thank you, Michelle, and to everyone. Have a wonderful day.
Thank you very much, and hope to connect. Bye bye.
Bye.